Determine the value of SS, or the sum of squared deviations, for the following sample data. So my sample is made up of 0, 0, 0, and a 2. And the answer is either 0, 1, 3, or 4. Now, one of the questions that I get from time to time is whether or not we need to bother with the zeros, seeing as they represent no value. Well, they do in fact contribute to a sum of squares, and you'll see here with the calculations how that works. Once again, as I'm always doing, I'm going to perform two separate calculations. I'm going to use the definitional formula. I'm also going to use the computational formula just to show you how to do it both ways. Okay, so let's start off with the definitional formula up top here. The definitional formula requires that I know my sample mean, which is the sum of x over n. So I need to add these up, which is pretty simple. It's just going to be 2, and divide that by the number of values. Now, even though these are zeros, they do count, and so the average here is going to be divided by 4. 4 different values went into making this up, so the average is 0.5. Okay, so I can now find my deviations, and so I've got what? 0 minus 0.5, that's negative 0.5. Same thing here, and here. And finally, 2 minus 0.5 is positive 1.5. I showed you in the previous video that if you add these up, it has to come out to be 0, no matter what the values are that went in. And so it does in fact come out to be 0, so I know that so far I'm doing things right. My next column has me squaring these, and so negative 0.5 squared is positive 0.25. And then I've got positive 0.25, positive 0.25, and then 1.5 squared, I believe, let's see, 1.5 squared is 2.25. Okay, I'm going to add these up to finish off my formula, because that will give me my sum of everything in the column. It's the sum of my squared deviations, and that's going to give me a total of 3. That is my sum of squares, 3. And so the answer is going to be C. Let's do this again, though, using the computational formula. So I'll put that down here. 0, 0, 0, and 2. That gives me sum of x equals to 2. And once again, you don't have to do both of these formulas. I'm just showing you two different methods for getting the same result. I need my squared values, which will be easy because 0 squared is still 0. 4 squared is just, 2 squared is just 4. When we sum these up, it's going to be how much? It's going to be 4. And my sum of squares is equals to the sum of x squared minus the sum of x in brackets squared over n. This comes out to be 4 minus 2 squared over 4. What is 2 squared? That's 4 divided by 4. This is going to be 4 minus 1, because 4 divided by 4 is 1. This gives me 3. So we get the same result that we got using the computational formula. The answer is 3.